Assalamualaikum warahmatullahi wabarakatuh. So today's lecture we are going to continue on statistic in sensory evaluations. Now it's about on principal component analysis. I hope all the students are doing fine and in health conditions in this situation, so can focus still on the school from home. And although with many limitations, we do hope that all the students can understand at least what is the principal component analysis and how to use the principal component analysis in the situations. I mean, in the practical situation. And the subtopic at the moment will be introduction to principal component analysis. What about the principle of the component analysis and the applications of principal component analysis? There will be both languages, Indonesian and English, because sometimes it is difficult to explain in English for certain understanding. So that's why I'm sorry if I may use bahasa to explain clearly about the topic. So it's one of the learning outcomes that after finishing this topic, the students can understanding the technique in principal component analysis and can describing the principle of a principal component analysis, of course. In the word, also actually it's multivariate. Yeah, all real processes actually multivariate. For example, the weather are also multivariate. You can see that not only one factor, but there are quite many numbers of factors. For example, the factor that related with the weather, wind, the velocity of the wind as well, air pressure, temperature, dew point, and also season. Sensor for the measurement through the weather, we can use also anemometer, barometer, thermometer, hygrometer, and also do the season calendar, for example. That's why multivariate or several sensor can related also later to multivariate mathematics or chemometric that we also knows at the moment. So all these situations, not only for the weather but also for the real situations, it's actually multivariate, not only single factor that really influence, but the other factor also will contribute to the situation. And a self or empirical modeling in science who aims to observe the processes with available instrumentation and measurement technique, because we cannot do all the measurements directly. So that's why sometime in labor we can only focus on one measurements or parameter only, or at least two parameter, or in a certain time we can use AutoSepra but cannot full all the parameter. Some processes follow laws of physics, or other theoretical model can be modeled from the first principle. Many other processes are complex in nature, as mentioned, and empirical data often form the basic for analysis. Multivariate methods are required to analyze the data with the functions or the aims to make use of background knowledge or theory for correct interpretations and for the most comprehensive validation. Of course, data analysis in practice, actually the 40% is application knowledge, 30% is common sense, 20% statistic, you know what statistic means, and 10% is mathematics. It's like we are on scramble. And definitions, back again to the definitions of the statistic because it is needed to understand or recap again the definitions. As last week, we do learn about the standard variation. So, variance is a measure of the spread of the variable's value, and covariance a measure of the linear association between variable, how a variable changes when another change. So that's the definitions of the covariance. Here is the functions you may read directly, and we also cover these functions from the last week lecture. Correlations is compare linear dependency, unitless covariance divided by the product respective to the standard deviations, of course. And multivariance analysis method types. Many methods to choose from depends on the type of the answer that you want. The first is data descriptions. Remember the type of the two statistic, descriptive statistic and inferential statistic. So here, multivariate analysis when your targeted is for data description or explorative data structure modeling. Sometimes looking at the data, characterizing the structure, and do the qualitative analysis. And PCA, as mentioned, is one of the descriptive statistics. So it is just describing data description. So it's not the inferential statistic, but you may get also the insight from the PCA data. And later, for example, multivariate analysis method can be discriminates and also do the classifications. Like, for example, separations of the group data, quantitative analysis, and hierarchical clustering analysis or HCA, SIMCA, using also the HPMs for discriminations and classifications. And later to see the correlations, we can do the regressions and also predictions like PLS, partially square, or MLS, yeah, relates to the variable or indirect observations. The target, as mentioned, the criteria of multivariate analysis, the variables has to at least more than or equal to 2 and simultaneous, so directly analyze simultan both together. The minimum is 2, of course. The complex calculations to produce the matrix, the classification, determinations, analysis, identifications, predictions, explorations, and also comparisons analysis. And to see the associations, we can do also relationship analysis. Sometime, for example, when we are as a real student, collect a lot of data, sometimes come across a lot data sets, and we do not realize that how big the data is until we are drowning or even exhausted with the data. And sometimes we are overwhelmed with the data. For example, when here I have the bucket table using the Excel 2003. It quite took a long time to open. So as you see nowadays, with the facilities or using some of the like, for example, using the HPLC, MSMS, or using the what is called many analysis resulted a bunch amounts of data. For example, this analysis is actually using This data actually using nuclear magnetic resonance, so you can see that it's quite a big number with one time running, and